Hello, welcome to the fifth lecture for the Mathematics Class 11, Chapter 8, Sequences and Series. So, we have begun with understanding what are sequences and different types of sequences, how we can solve for different kinds of sequences, whether we are given a few terms of the sequences or we are given in some kind of a general formula. We also saw how we solve for arithmetic sequences. Okay, so these are some things that we have seen. We also started with understanding what are series, okay, and how we can calculate it for arithmetic sequences. So we will do a few sums. We will start with a few problems. In some of them, they will be in the general arithmetic sequence form, and in some, it is not always possible to, define the common difference. Okay, so and if we have to find the sum of the terms up to some, nth term, so we will probably might have to do the manual calculation, because sometimes the series does not follow a very set kind of a rule. Okay, so with that in mind, let's do the first problem. So suppose the question given to you is, in a sequence, the fourth term is minus 20 and the eighth term is minus 10. So what is the 100th term? Okay, so now over here we can see that we have A4 is equals to minus 20. Okay, and A8 is equals to minus 10. Okay, so we are explicitly not told that, whether this is arithmetic sequence or not. So we will just, include that in this. Suppose this is an arithmetic sequence. Okay, so for arithmetic sequence to find our A100, okay, we need the common difference D, and we also need the first term of the sequence. Okay, so to get your D or A1, okay, so first we will write our A4 in the general term formula. So that is, so you have A1 plus your N minus 1. Okay, so your N is what? 4 minus 1B. So this becomes A1 plus 3D, and we already know that A4 is minus 20. So let this be your equation 1. Then your A8 is equals to A1 plus 8 minus 1. A1 plus 7B is equals to minus 10. So this is your second one. So we can then subtract 2 from 1. We will get, so your A1 gets cancelled. What you are left with is minus 4D is equals to minus 10. So therefore, your D is equals to 5 by 2. Okay, so let's, we got our D. Okay, and we will now find our A1. Okay, so just substitute A1 in any of the equations. Substitute for D in any of the equation. A1 plus 7D is equals to minus 10. Okay, so let's take this. So A1 plus 7 into 5 by 2 minus 10. So this is A1 equals to minus 10 minus 35 by 2. So this you get as minus 55 by 2. Okay. So either you can, convert it into decimal form, but let's just keep it in the fractional form right now. So now we have to find our A10. Sorry, we have to find our A100. Okay, so A100 would be A1 100 minus 1 D. Okay, so that is minus 55 by 2 our A1 plus 99 multiplied by we have 5 by 2. Okay, so this on solving you will get 440 by 2 and A100 is 220. Okay, so this is how we solve this kind of problems. Let's see a few more. Okay, so suppose we are given to 10th term in the sequence 1, 2, 4, 7, 11. Okay, so over here you can see your A1 is equals to 1, A2 is equals to 2, A3 is equals to 4, A4 is equals to 7, and A5 is equals to 11. Okay, so over here we can see this. Now, if you observe, if you try to find D over here, okay, so you will have A2 minus A1, so that would be your 1. But when you go to find A3 minus A2, you will find that there is a difference of 2. Similarly, with A4 minus A3, the difference is now 3. So you can see the difference, okay, between the two consecutive terms in the sequence is actually increasing by 1 itself. Okay, so we can understand that there is no particular, there is no definite D over here. So how can we go, with trying to find the term of it? So you can observe that your A2 is actually A1 plus 1. Okay, because your difference, suppose we write it in that form also. Okay, and your A3, where it is 4. Okay, so this becomes actually A2, which is 2, and then plus 2. Okay, so if you just do, then your A4 becomes A3 plus 3, and your A5 also eventually you'll see it will become A4 plus 4. Okay, so in this you can find a pattern that this A2 can also be written as, A AN can be written as where your A2, okay, then A1 can become A minus, sorry, N minus 1, and plus 1, 1, and this one is the same, so you can write this as N minus 1. Okay, so this is the general formula for nth term. Okay, with respect to this, you don't really need any, D. You can directly solve for different terms. Okay, so now you want to find up to the 10th term. So we have till A5. We will go for A6. So A6 would then be A5 because AN minus 1 plus N minus 1. So this will be plus 5. So A5 was 11 plus 5 equals to 16. Okay, similarly, your A7 will then become A6 plus 6. So A6 is your 16 and then plus 6. So this is 22. A8 will also become the same, that is A7 plus 7. So A7 is 22 and plus 7, 29. A9 will be A8 plus 8. Okay, so 29 plus 8 is equals to 37. And your A10 would be A9 plus 9. So 37 plus 9 is equals to 46. So if we have to find the sum of these terms, okay, sum of the 10 terms. Okay, since now we don't have one certain D, it is difficult for us to, calculate it just like, with a specific formula. So if you add all of your terms, your sum will actually turn out to be 175. Okay, so this is a type of sequence that can be got. Obviously, when we learn the more different kind of sequences, maybe we can define such sequences better. We'll see. Let's take another question. Excuse me just a moment. I'll have some more. Okay, so let's take another question. So consider the sequence x n is equals to half n squared plus n minus 2. Okay, find the next two terms where xn is 0, 2, 5, 9. Okay, so this is suppose a kind of question that you ask. Over here also, if you like we did in the previous kind of sum, we could usually find a sort of pattern over here. So over here, if you're like a1 is equals to 0 and your a2 is equals to 2. Okay, so if you find the difference, so a2 minus a1 is equals to 2. Okay, and therefore you can write that a2 is equals to a1 plus 2. Now again over here you can see that there's a relation, and similarly if you have a3 is equals to 5, so a3 minus a2 is equals to 3, and therefore a3 is equals to a2 plus 3. So over here you can see that this can be of the sequence can also be written in the form where an is equals to an minus 1 plus n. Okay, whatever your n is, you add with that. But over here we are already given a different kind of a general expression over here for the sequence, so we will use that. Now over here we have got up to the fourth term, so we will find we have been asked to find the next two terms. So the next two terms, so the first term would be x5. Okay, so that will be half 5 squared plus 5 minus 2. So that is half multiplied by 25 plus 3. So that is 28. So 28 by 2. So your term is going to be 14. Okay. If you want to cross check with respect to this, your A5 would be A4. So that is 9. And you will have N. So N is 5 over here. That too is 14. Okay, let's take the other one. So x6 is half, and this will be 6 squared plus 6 minus 2, and this is half multiplied by 36 plus 4. So 36 plus, sorry, this will be 4. Yeah. So 36 plus 4 is 40. So 40 by 2. So you have the next term as 20. Similarly, if we take it like this, a6 plus your 14 plus 6. Okay, A6 is equals to 14 plus 6. So this is also again 20. Okay, so both ways you can find. So obviously this, where you have to find this sequence, you will have to look at the your terms very carefully and understand the pattern or the relation that is being followed by the sequence. Okay. Take a question where your a n is equals to n squared plus 5 by 4. Okay, and we are asked find the first 6 terms in the corresponding series. Okay, so let's find our A1, A2, A3 all the way up to A6 first. So your A1 would be 1 multiplied by 1 square plus 5 is 4. That is 1 plus 5 is 6, 6 by 4. So you get this as 2, 3, 3 by 2. Then your A2 is going to be n is 2, so 2 into 2 squared, so 4 plus 5 upon 4. Okay, so this is 2. So this becomes 9 by 2. Then you have A3. A3 is 3 into you have 3 squared, so 9 plus 5 is 14. 14 by 4, so this 7, so this is 21 by 2. Okay, now you have A4. So A4 would be 4 multiplied by 16 plus 5 by 4. Okay, so 4 gets cancelled. So you have 21 here. Then you have A5. So that is 5 multiplied by n squared. So that is 5 squared, 25 plus 5 by 4. So this would be 5 into 30 upon 4. So 2, 15. 75 by 2. And then we have A6. So A6 you will have 6 multiplied by 36 plus 5 by, sorry, yeah, oh no, this will be 5 by 2. So 3, this is 4, yeah, 2, 2, 3. So 36 plus 5 is going to be 41. So 41 into 3 is 123 by 2. Okay, so we found all the first 6 terms of the sequence. Okay, now let us find the sum. Now over here, we are probably not going to, or if we have, let's see if we can find any D. So your A2 minus A1 is equals to 9 by 2 minus 3 by 2. So this is actually 3 by 2. Okay, sorry, 6 by 2, not 3 by 2. 6 by 2. Let's see for A3 minus A2. So our A3 is 21 by 2 and this is minus 9 by 2. So this will be 1 by 2. So this is actually 4 and this is also 3. Okay, so we are seeing that this is 6, sorry. So we are seeing that the D is not, constant. So this is not an arithmetic series. So what we can do is to find the series. So we'll find the sum of all 6 terms. Okay, so that way this will be 3 by 2 plus 9 by 2 plus 21 by 2 plus 21 plus 75 by 2 plus 123 by 2. Okay, so we can take the common denominator as 2. So you have 3 plus 9 plus now 21 will be 21 will be multiplied by 2 here. So this is 42 plus 75 plus 123. Okay, so we have this. So if we sum them all together, we get 3 plus 9 is 12 plus 21, 33 plus 42, 75 plus 75 and 50 plus 123. So what we get is 273 by 2. Okay, so this is a sum. So again, we are slowly, seeing that it's not always possible to have, arithmetic sequences. We do have sequences which follow a different kind of pattern too, other than arithmetic sequences. So let's take few more examples. Okay. So suppose we are being asked how many three-digit numbers are divisible by 7. Okay, so suppose you are asked to find the number of three-digit numbers. Okay, the total number of three-digit numbers that are divisible by 7. Okay, so to find that, let's see the first. Okay, so the first three-digit number divisible by 7 is 105. Okay, and the last three-digit number divisible by 7 is actually 994. Okay, so we have this. So as per this, we have our first term as A1 is equals to 105. The last term, okay, we don't know which term, so your AN is equals to 994. Okay, and then your D, okay, so since all the numbers are divisible by 7, so the difference between two consecutive numbers in such a sequence is going to be 7 itself. So your D is equals to 7. So what we have to find is the N. So therefore, using the formula of AN is equals to A1 plus N minus 1 D, then we get A1 is 105 plus N minus 1, 7. Okay, and that is going to be equal to 994. So therefore, 994 plus 205 plus 7n minus 7. So therefore, 7n is equals to 994 minus 105 minus 7 would be 98. So this is 896, 7n. So therefore, n is 896 divided by 7, so that is 128. Okay, so there are 128 numbers between 105 and 994, okay, which are divisible by 7. Okay, actually not between 105 to 994, it is starting from 105 up to 994. Okay, all the terms. So there are 128 terms, three-digit numbers which are divisible by 7. Okay, so let's see another kind of a question. We have find the first term of an AP, so arithmetic progression, if D is equals to minus 4 and the seventh term is 6. Okay, so now we have to find the first term. So our A7 is equals to 6 and B is equals to 4. So therefore, our AN, so this is the formula that we have. So we have A7. Okay, so A7 would be your A1 plus 7 minus 1 D. So that is 6 is equals to A1 plus you have 6 multiplied by 4. Oh, sorry, D is minus 4. Yeah, so this would be minus 4. Okay, so your A1 then becomes 6 plus 24, and that is 13. Okay, let's check or let's do the sum. So you have Q is equals to, now your question is find the sum of all even numbers from 2 to 102. Okay, so over here we have our A1 is equals to 2, AN, okay, is equals to 102. We don't know our N, okay. And the difference, since the common difference, since the sequence itself is, all even numbers, okay, starting from 2. So with even numbers, the common difference between the two terms eventually comes up to as 2. So we have all of these and we have to find our N first. So AN is equals to A1 plus N minus 1D. Okay, so your A1 is 2, AN is 102 plus N minus 1 and you have D. So you will have 2 plus 2 N minus 2 and 2. So 2 and minus 2 gets cancelled. So therefore your N or 2N is equals to 102. So therefore N is equals to 51. Okay, so we have 51 terms in total from say 2 to 102 even numbers. Okay, so now we will find our S51. Okay, so the sum of the series. So now we have all the terms which are required. You have N and you have A1 and D. So you can substitute it in the formula of N minus 1 to A1 plus N minus 1 D. Okay, so this then becomes N by 2 and you have, sorry, your N is 51 already. We have got 51 by 2. So 2 into your A1 is 2 and plus you have 51 minus 1 multiplied by 2. So this then becomes 51, okay, multiplied by you have 2 plus you have 50. This is 51 multiplied by 52 and that actually comes up to be 51 is equals to 2652. Okay, so this is the sum of all the even numbers from the from 2 to 102. Okay, let's take another example. So suppose we have been asked, find the 28th term from the end of AP, that is 6, 9, 12, 15, 18, all the way up to 102. Okay, so now we have been asked to find the 28th term from the end of the arithmetic progression. Okay. So to find that, we first have to find how many terms are there in the sequence. Okay, so we have our A1, we have our AN 102, and we have our D. So D, as you can see, is 3. Okay, so using our formula of AN is equals to A1 plus N minus 1D, we can find what is N first. So your AN is 102, A1 is 6, this will remain as N minus 1, and our D is 3. So therefore, you get 102 is equal to 6 plus 3n minus 3. So therefore, 3n is equals to 102 minus 3. So that is 99. So therefore, your n is 33. Okay, so now we are saying that our n is 33. Now when we have to find a particular term, okay, so suppose we are finding or we have been giving that the r, suppose any term, okay, the rth term from the end of the arithmetic progression can be given with respect to a certain uh, will actually be some term that's just starting from the first term of the AP. Okay, so you can actually write that your AR, okay, from the end will be is the n minus r plus 1 term from the beginning. Okay, so whenever suppose you are given, say your A1, A2, A3, A4, A5, A6. Okay, so we have 6 terms. Okay, now if you want to find the fourth term from the end. Okay, so fourth term from A6 would be, this would be 1, 2, 3, 4. Okay, so fourth term from end is actually the third term. Okay, so the third term from beginning. Okay, so if you just directly minus, say n minus 4, you will actually get it as 2. So which is wrong. It is not the second term. It is the third term. So that's why when you calculate in that form, okay, so what you have is that n minus 4 plus 1. Okay, so that will give you the correct position of the term. So AR, okay, so AR from the end is the n minus r plus 1 third term from the beginning. So therefore, when we are being asked the 28th term from the end of the AP is, say, n minus r plus 1. Okay, so this will be our n is 33. Okay, so 33, and our r is now given as 28 plus 1. So that is our 6. Okay, So is the sixth term from the beginning. Okay. So this then becomes, so therefore we will find A6 is equals to our A1 is 6 plus N is 33 minus 1 and our D is 3. So you will get this as 6 plus, oh sorry, this will be 33. Our N is 6 over here. Yeah, mistake, sorry. So this will be N is your 6. So that is 5. So this is 15 and this is 21. Okay. So similarly, suppose, if you are asked 15th term from the end. Okay. So let's first find which term it will be from the beginning. So that would be 33 minus 15 plus 1. Okay, so 33 minus 15 will be your 18, 18 plus 1. So this is the 19. Okay, so we have to find A19. Okay, A19 from start. So what would be your A19? So that would be 6 plus 19 minus 1 multiplied by 3. So this will be your 6 plus 18 multiplied by 3. So that is 6 plus 4 to 54. Okay, so this would be your 60. Okay, so this is how we can find. And suppose you are asked then, to find the series, the corresponding series for this. So keep, suppose you are also finding, find the corresponding series. Okay, so we have n is equals to 33 here and d is equals to 3 and our a1 is 6. So therefore we can find, now we already know, we can see that since we have a d, this is an arithmetic progression or sequence. So we can directly find our Sn as your n by 2, 2a plus n minus 1 d. Okay, so this will be 33 divided by 2. So you have 2 into 6 plus 33 minus 1, 3. So this will be 33. This will be multiplied by, this will be 6 plus, say, 33 minus 1 is 32. So 32 divided by 2 would be 1, 6 into 3. So 33, 6 plus 8, 148 multiplied by 6 plus 48. So this is 54. Okay, so 33 into 54 is equals to 1782. Okay, so you see, when you know the formula, okay, and even if you don't have a particular arithmetic sequence that is given to you in the question, it is still easy for us to, find. And you can also see, like, in the term of your Sn. Okay, so when you are considering, say, your Sn, okay, Sn, we write it in the form of n by 2, 2a plus n minus 1 d. Okay, so suppose, you do not always have to, put your values of, a and every time. You can actually write this in the form of, say, suppose this is your A1, okay, is the first. So A1 plus a1 plus n minus 1 d. So now you can see that this is actually in the form of a n. So this actually comes down to your, n by 2, the sum of the first term plus the last term. Okay, so if you have your first term and if you have your last term with you, you can easily find the, sum of the sequence that is given to you. Okay, so let's just take an example and see how this actually does is actually true. Okay, so suppose the question is that, okay, so we have done this question before, so we just want to see if that actually if we have the first term and the last term, can we directly solve for the Sn without going into the entire substituting for n any the entire a1 and n in the formula. So we had done this to find the sum of odd integers from 1 to 2001. Okay, so we had solved this, I think, in the previous lecture. So we will just, if we, the n we had found as 1001. Okay, we need n for the, the first part of that formula. But now we know our a1 is equals to 1 and our an, so that is a1001 is actually 2001. Okay, so if we just, let's see Sn, so n by 2, suppose you write as a1 and an. Okay, so our n is 1001 by 2. Okay, and this then becomes your 1 plus 2001. Okay, so this actually becomes your 1001 and multiplied by 2002. Okay, divided by 2. So this eventually becomes 1001 multiplied by this is 1001. And we had got this, in the similar way. So you have 100201. Okay, so you see it's easy if you know your first and the last term already. Okay, and you just solve it just using the first and the last term. You can this is for arithmetic progression. Okay, so can you know this can be used for arithmetic progression or sequence. Okay, so till now we have seen, how we solve for mostly arithmetic progression, arithmetic sequence. We also looked at some examples which are not arithmetic sequence. Okay, so some of them could be your, kind of harmonic progression. Some could be your, geometric progression also, and some just, follow a certain kind of a rule which may not be, easily categorized as any of the type of sequences. Okay, so we have seen all that till now. So in the next class, from the next class, we will start with, geometric progression, and we will go further into the chapter where we will also see some different kinds of, concepts like geometric mean and also, few more than that. So we will stop here for today.